Okay. Hello, my name is my wife Franco, and I'll be talking about the object pool design pattern. This is the coverage for the presentation. I'll be talking about the definition, intent, motivation, all those other things listed there. And eventually I will be showing off my implementation of the program. The definition of the design of the object pool design pattern is it's a creational pattern where you have objects put in a pool where they will be used and then reused instead of created every time they're needed. So a client of the pool will make a request for an object, and then the pool will provide an object if it's available for the client to use it. When the client is done, the object will be released back into the pool so it can be reused later on. The intent is to improve the memory performance by reusing objects that are already created, so there won't be a need to create an object every time it's needed, especially when it comes to large objects. It can provide a significant performance boost, and it's also mostly effective in situations where the cost of initializing an object is really large, and when you have a class where you have a high number of instantiations and a low number of objects being used at any single time. The motivation, this is just a simple example to explain why the object pool pattern is used. So if you have a video game where a character does something and then a lot of visual effects take place, this takes a lot of time to create all those particles. So this pattern is used to create those particles ahead of time, and then whenever they are needed, they're requested and then used by the clients because there's such a high number of those particles. It wouldn't make sense to create them every time they're needed, and that would cause a lot of issues, and it would waste a lot of time, and there would be a lot of stalling in the program for um, in the time it's waiting for the particles to be created. So the object pool pattern is used, and they're just requested whenever they're needed. Known uses, again, video games are the main area where it's used, and also with playing sounds and sound effects. If you have a situation where you frequently need to create and destroy objects, that would be useful because it would save a lot of time on creating and destroying those objects. If you have a situation where objects are similar in size or identical, this will also be helpful. Um, if it allows you to avoid memory fragmentation, that would also be a good place to use the pattern. And if you have large objects that need to be created, such as a database connection or um, uh, anything like that, that would also be an ideal position to use this pattern because you wouldn't have to create a database connection and waste time on that. The improvements, benefits, the performance boost is the biggest benefit of this pattern, where the cost of initializing an object is extremely high, and especially if the rate of instantiation is low or high. I'm sorry. Um, this is where the objects. This is where it would be a good idea to have the objects be put in a pool and then just requested whenever they're needed. The consequences of using the object pool design pattern is that memory might be wasted if you have a large number of items in the pool, but not all of them are used. Then that would cause an issue. And also only a fixed number can be used at any time, can be available. So if you have 10 objects in the pool and you need 12 or 15 or whatever, then that's gonna cause an issue because the client will have to wait for an object to be free. And also if you have um, objects where the memory size is different for each one, where you have different variables in each object, that would not be ideal in this case because the object pool uses objects of the same type. And also reusing objects and using objects might not be automatically cleared. They need to have um, methods called on them to be completely cleaned and rehabilitated such in a way that they'd work for other clients. And unused objects will also um, remain in memory unless they are absolutely cleared. Now this is the class diagram for the project that I created. We have basically a machine as the object and a machine pool. A pool will have keep track of the available machines and the in-use ones, and a machine is just a generic factory machine where it has an ID, a location, and an object that it's building, and a few other methods. Um, okay, so on to the implementation. This is just a snap of the results. This is the code. This is the machine class where you'd have a constructor and have the machine ID and location and the object it's currently building. These are just a few methods that represent the business logic of the machine object. You have identify, you just identify the machine as it is, go to location, build, drop. They don't really do anything in this case, they just print a message, but if the machine object actually did anything from a business logic perspective, this is what it would be done. And you also have a show message where it would just display a message. So I'll just take a quick look at this. It's very simple. This is the machine pool. There's the available and in use lists. I've restricted them to 5 machines in this case. This is where the pool will be initialized. 5 machines will be created the first time the pool is initialized. Get machine will return a machine from the pool. It will take one. It will take one from the available pool, add it to the in-use one, and return it. And it will also throw an exception if a machine is requested when there are none available. Release machine is when a machine is released by the client. It'll be reset, which will delete everything related to that particular machine and reset it to its original form and put it back into the pool. It will put it back into the available pool and remove it from the in-use one. Reset will call a function that does whatever business logic that's associated with the object, and we'll also tell it to go back to storage. It's also business logic, and might also clear up pointers and whatever that is, if there's anything like that. This is the main function. This is the driver program. 2 machines are created, and then a bunch of methods are called on them. Identify, go to location, build. Again, these don't do anything except print out messages, but if they did anything, this is where they would do it. So a machine would be created, would be requested from the pool, assigned to a variable, and then it does whatever it's needed to do for the client, and then once it's done, it will be released back into the pool. Quick demo. So machines 1 and 2 are created, they're identified as whatever they are. This is the machines actually performing the task that the client wants them to perform. It's just putting out all these messages in this case, and once they're done, they're released back. And this is here just to showcase that when more machines are requested than there are available, an exception will be thrown and the user will be notified. And this is pretty much it. This is the object pool design pattern. Thank you for watching.